In this video, we delve into the fascinating world of neural networks, the fundamental building blocks of computer learning. Whether you're a beginner or have some knowledge in the field, this video will provide you with a solid foundation for understanding how neural networks work. Introduction to neural networks. Brief overview of the concept and importance of neural networks in computer learning. Neurons, the basic units. Explanation of neurons, their structure, and how they process information. Discussion on activation functions and their role in determining neuron outputs. Layers and architectures. Introduction to layers and their organization in neural networks. Overview of different network architectures such as feed-forward, recurrent, and convolutional neural networks. Training neural networks. Explanation of the training process, including forward and backward propagation. Discussion on loss functions and gradient descent optimization. Deep learning and applications. Introduction to deep learning and its relationship to neural networks. Showcase of various applications of neural networks, such as image recognition, natural language processing, and autonomous driving. Tips for building neural networks. Practical advice on designing and training neural networks effectively. Consideration of hyperparameters, data pre-processing, and regularization techniques. Conclusion and next steps. Recap of key concepts covered in the video. Suggested resources and next steps for further exploration of neural networks. By the end of this video, you'll have a solid understanding of neural networks and their role in computer learning. Stay tuned for more videos on our channel as we explore advanced topics and practical applications in the exciting field of artificial intelligence and machine learning.
Introduction to neural networks. Neural networks are a class of machine learning models inspired by the structure and functioning of the human brain. They consist of interconnected nodes called neurons that process and transmit information. By leveraging this interconnectedness, neural networks can learn patterns and make predictions from input data, enabling them to excel in tasks such as image recognition, natural language processing, and more. Neurons. The basic units. Neurons are the fundamental units of a neural network. They mimic the behavior of biological neurons and serve as information processing units. Each neuron receives inputs, performs a computation on them, and produces an output. The inputs are weighted based on their importance, and the neuron applies an activation function to determine its output value. This output is then transmitted to other neurons in the network, enabling the flow of information and the learning process. Layers and architectures. Neural networks are organized into layers, which are sequential collections of neurons. Each layer serves a specific purpose in information processing. The input layer receives the initial data, while the output layer produces the final prediction or output. In between, there can be one or more hidden layers, which perform intermediate computations and help the network learn complex representations. The arrangement and connection patterns of these layers form the architecture of a neural network, such as feedforward, recurrent, or convolutional, determining its capabilities and functionality. Training neural networks. Explanation of the training process, including forward and backward propagation. Discussion on loss functions and gradient descent optimization. Deep learning and applications. Deep learning is a subset of machine learning that utilizes deep neural networks with multiple layers to extract hierarchical representations from data. It enables the automatic learning of features at various levels of abstraction, leading to improved performance in tasks such as image and speech recognition, natural language processing, and recommendation systems. Deep learning has found applications in diverse domains, including healthcare, finance, autonomous vehicles, and computer vision, revolutionizing industries and pushing the boundaries of artificial intelligence. Tips for building neural networks. Here are some tips for building neural networks. Start with a simple architecture and gradually increase complexity. Begin with a basic network structure and add complexity as needed. This approach helps in understanding the impact of different architectural choices and prevents overfitting. Gather and preprocess high-quality data. Data quality is crucial for the performance of neural networks. Collect a diverse and representative dataset. Preprocess it properly by handling missing values, scaling features, and balancing classes if necessary. Regularize to avoid overfitting. Implement regularization techniques like dropout, L1 per liter 2 regularization, or early stopping to prevent overfitting and improve generalization of the network. Optimize hyperparameters. Experiment with different hyperparameters such as learning rate, batch size, and network size to find the best combination that yields optimal performance on your specific task. Use techniques like grid search or random search to efficiently explore the hyperparameter space. Conclusion and next steps. In conclusion, neural networks have revolutionized the field of machine learning by enabling the development of powerful models capable of complex pattern recognition and prediction. Their ability to learn from data and adapt to new information makes them versatile and applicable in various domains. To further explore neural networks, it is recommended to delve into advanced architectures, optimization techniques, and specialized applications to continue pushing the boundaries of AI and harness the full potential of these powerful models.